Hey, what's going on everybody? It's Caleb. Welcome to your FastAPI tutorial. We're going to build out an API from scratch using the FastAPI framework in Python. So this is the perfect starting point if you're relatively new to building out APIs. We're going to lay the foundation, get that hands-on experience, and we'll have additional material in future lessons. So I wanted to call out the playlist link. You can start from the beginning of the playlist to get all of the API concepts, or you can start with this video if you want to jump in on hands-on material. Additionally, I will have extensive notes for anything we talk about in this lesson, as well as copyable code samples and references for any other topics you might want to do additional research on. So I'll have a link to get the notes in the description as well. So let's get started with first talking about what FastAPI is. Well, it's one of a couple popular frameworks for web development in Python. Two other popular ones are Django and Flask. I've also done videos like this covering Flask and Django, but there are some very unique benefits to FastAPI. So this is the FastAPI website. A couple of quick things to call out. Well, first, it's fast, but a big thing is that it's fast to code. We're going to build out a pretty intense API relatively quickly. Not only building the API, but also having very clear documentation for that API being generated for us. And this is huge. It's going to make consuming the API so much easier. By the end of this, you'll have an API that adheres to the OpenAPI spec, which will give you a very nice interface. And as mentioned, make it much easier to consume the API. And it'll say the types of data and the structure that the client, the consumer of the API, should use to interact with the API. And this structure will be enforced on the backend. FastAPI is built with Pydantic, and this is the most widely used data validation library for Python. So not only will we tell the user of the API what structure we're expecting, we will enforce that with some data validation, and this is pretty much out of the box ready to go, which is something that for other libraries and frameworks could take a lot of additional work. So before we jump into the code, let's take a look at what we'll build in this lesson. And this is just a starting point. As I mentioned, we're going to continue building upon this in the upcoming videos. So there's a lot of things we won't get to cover in this video, but I'm going to cover the most thorough foundation so that the future lessons will be able to continue right where we left off. So here's a look at what the final product of this video is going to be. We will have a series of CRUD capability API endpoints. We'll be able to read our list of campaigns and we'll be able to try it out in the browser so you can see all the different campaigns that exist. We'll be able to get a campaign by ID. So you can pass in ID 1, for example. This will give you a specific campaign. We'll be able to update a campaign, give some new data, and this will update it in the database and give back that new change. We'll be able to delete data. So we can go in here, delete ID 1, get it to a full response saying it was deleted, and we will be able to create new campaigns as well. This one is new. And this will give you a 201 and give you back the data from the database. Additionally, these will give you the potential error codes or response codes you could get. So you can get validation errors for the data, as well as successful responses. And if there's any other special response possibilities, they'll show up there. And then lastly, we'll have the schemas. So these are the different types of data you might expect to work with. So we have a campaign. This can be expanded and you can see that structure. We'll have a slightly smaller campaign create with a name and a due date. We'll also have these other things such as a response with a list of campaigns or a response with a single campaign. So this pretty much gives the full interface for working with the API. So the goal of this video is to build this out. Now I'm going to be running this off from Mac. If you're on Windows, you can follow along as well, but the commands might be slightly different in certain scenarios, or you can run WSL if you would like. But the very first thing we're going to do is we're going to create a directory for our project. Now you can decide what you want to call this directory. I just came up with a project name for what I'm trying to build. So the idea that I have is an app that will help with writing content for marketing campaigns. So if you want to write some copy and you want to distribute that across social media, newsletter, website, everything, basically have it in all locations, that's the idea of this application. And I decided to call it Omnicopy. So you can follow along with this example or do your own, but we're going to say mkdir Omnicopy. We will open that directory. And now we will create a virtual environment. So we'll use the venv command and we'll call the virtual environment .venv. Then we can activate it. So space .venv bin activate. I think if you're on Windows, this is where it will differ. It'll be like /scripts/activate or something like that. But yeah, you can look up the exact commands if you're on Windows. Now we're also going to set this up with Git right from the beginning. So we're going to create a .gitignore, and we're going to put in that the .venv directory. So we'll put this in .gitignore. So now we should have, if you do an ls-a .gitignore and a .venv, and the gitignore just has .venv in it so far. Cool, so far so good. Now what we're going to do is we're going to upgrade pip, the package installer for Python, and then we will use it to install FastAPI. So pip install -- upgrade, successfully installed, and then we'll say pip install FastAPI, and you have the option to specify what features or portions that you want to install. To do this, you'll wrap it in quotes, and then we'll just say standard. Now, when you finish installing stuff, you will want to add this to a requirements.txt file. So we'll say pip freeze, redirect that into requirements.txt. So now we have this file, and you can see what's inside of that. It's just all of the packages that we've installed. So that way we can use this list to install these later if we download this project on a new computer or need to recreate our virtual environment. Now we will say git init to initialize an empty repository. Git add dot, git commit, initial commit. Now we'll create a file main.py, and that's where we're going to write all of our Python code. Now at this point, I'm going to switch over to Visual Studio Code, so I'm going to open this directory in code. So this is what our file structure is going to look like, and then we can open a new terminal. Now we can run everything from here. Now my Visual Studio Code is automatically activating that virtual environment. If yours does not, then you will need to do that. So again, that's just going to be .venv bin activate. And then you'll see .venv over here on the left, which will tell you that the virtual environment is active. Now getting started is quite easy. We will open up main.py, and we'll say from FastAPI, import FastAPI. And then we'll say app is an instance of FastAPI. Now basically we create a function that we associate to a path. So we'll say app.get, and then in quotes, the path to hit this function. And we'll say def, and these are going to be async functions. And then we'll just return a value. We will return a dictionary, and we can say something like message is hello world. So this is the most basic FastAPI app we could build. And then to run, you'll say FastAPI dev, and then the name of the file main.py. And then this will show up some stuff here, as well as give you the URLs to access the API. So we will open this, and this is our site. Additionally, you'll also have a documentation site. So you can go to /docs, and this is our Swagger interface, and you can see the endpoints here. So you can expand them with this dropdown and see the potential responses you could get and what the value might be. So as we go, I'll talk about how to customize all of this. But the reason this works is because the FastAPI framework generates for you. You can go to /openapi.json. This JSON file, which is used to generate that Swagger interface. So there's Swagger, and then there's OpenAPI, very closely related. Just think of OpenAPI, the actual spec, the structure here for your API. And then you can think of Swagger as this interface. So we have the OpenAPI specification, and then Swagger is a suite of open source tools that implement and work with the OpenAPI specification. So yeah, you might hear some overlap between these two, closely associated, but slightly different. But yeah, this is really awesome because this makes documenting and sharing your API with others so much easier. So this is awesome. I built a Rust API, and I had to build all this out manually. It was such a pain. I mean, it wasn't that difficult. You can just build these API JSON files manually even. But even the library I was working with was supposed to make it easier, and it was still much more difficult than doing it with FastAPI. So this is probably my favorite feature. So let's just review each thing here real quick. So first we import, no big deal. Then we create an instance and we assign it to app. So then whenever we want to refer to our FastAPI instance, we use app. We use a decorator here, and this describes how we associate a web page visit to a certain function. You might hear path operation function. So in OpenAPI and within FastAPI, an operation would be one of the HTTP methods such as get. So for every method and every path, we're going to have a function that handles that request. So we have the basic structure here, but one other thing I wanted to mention is from the extensions, you will probably want to get Pylance. So make sure you have the Python extension and then the Pylance extension. And then from within your user settings, I added this python.analysis type checking mode strict. Having this extension, it will give us the most likely chance that we'll have issues pop up here in the problems. And you might need to reset Visual Studio Code if you just installed it. So now if I go in here and I put something bogus, it'll give me some warnings saying that these don't exist. And you can see it comes from Pylance. So now let's take a look at building an API. I gave you a brief overview of what app I wanted to build. Doesn't really matter at this point because we're not going to get into too many domain specific things, but I'm going to paste a basic data structure you might expect to work with for this app. So it'll look something like this, and I'm just going to comment this out. So I'll just make a giant multi-line comment. We won't keep this the whole time. I just want to show you guys without having to look at a bunch of errors. So the idea is you run some marketing campaign. The campaign has a date where the event launches or ends, basically some date to tie everything to. And then within that campaign, you have a bunch of pieces. So marketing pieces, content pieces. You can think of a social media post, a blog post, a newsletter. Any of these things would be considered a piece. Just getting started, I only want to worry about one of these. So we'll worry about the one you have to create first, which would be the campaign. Since a piece relies on a campaign being built, we're going to look at campaigns. Then when we get to relationships, we'll be able to make an association between these two types so that we can look at all of the pieces for a certain campaign, for example. So that's on my to-do, but right now I just want to focus on the campaigns. So this will have an ID, a name, some due date, and I guess I'll just be consistent here and use underscores, and then a created at. Now the created at, that's something that's typically just going to be generated either by the backend or the database, whereas the due date, that's going to be set by the user. So to distinguish between those, I usually will end the timestamp automatic stuff with at. So, this was created at this point in time, whereas due date sounds a little bit more like a manual value that you would be expected to put into the database. Hopefully that makes sense. But as we get into building a data structure, this is what we're working towards. Now, as for this campaign ID, that could be either campaign ID or just ID. Either one of those is fine. I've kind of grown to like having the table name prefixing the ID. I think it makes joins easier, but I think just having ID is also fine. So let's see what it would look like to create a new endpoint to retrieve the campaigns that we're working with. We can say app.get, and I will have these problems running, but I'm not going to keep that open because I find it very difficult to look at those problems constantly updating, or I find it quite distracting. So we'll make a new get, and then what do we put for the path here? Well, the path I want to have is basically /API /v1 for version 1, and then /campaigns. However, if we have a bunch of these endpoints and we're constantly repeating this section, that can be a bit annoying. So what you can do is you can take this and you can remove it, I'll cut it, and when we instantiate FastAPI, we can provide into this a named parameter of root path and paste that value, and you'll want that to be quoted. So now what it's going to do is it's going to take this root path, append the path for the endpoint to give you the full path. Now it doesn't worry about localhost or any of that stuff. This is just a path after that point. And then we'll create a function down here, async def. And then the naming for this is typically going to be the action. So create, read, update, or delete, followed by the resource. So for example, we'll have read campaigns. And to get started, just so I can see this endpoint in the browser, I'm just going to say return campaigns and then a colon, and then I'll just say example. So let's check if we can first hit this endpoint, and then we'll worry about filling in the data. So we'll go over to the browser. We'll go to /API/v1/campaigns and make sure your server is running. I'll probably forget to do that about 300 times, so just bear with me. FastAPI dev main.py. All right, we got that running. We can go do a refresh. Okay, so we know we can hit that endpoint. Now we can worry about getting data to show up here. Now what I'm going to do is very quickly mock the data with a dictionary, so that way we're not working with a database. And I know this can be a little bit annoying because we have to build up all these steps, but I think jumping directly to working with the database is quite the jump. We are going to do that in this lesson, but there's a little bit of a learning curve. So what I want to do is I want to first build out all of the endpoints we're going to work with and have a very basic structure. So that way we have the interface to working with our API pretty much done. So we'll be able to create that mock data very quickly, and then it'll make the next step a lot easier where we just have to swap it out for the database. So what's that going to look like practically? We're going to create a variable here, data, and this is going to be a dictionary. I lied, guys. I'm terrible. It's going to be an array of dictionaries. And that's because we're going to be getting multiple campaigns. So that's going to be an array full of dictionaries. But ultimately, we're going to put that inside of a dictionary. I talked a bit about this in the API concepts video earlier in this playlist. So we'll say campaigns, and then the value for this will be data. So now let's go and fill out what data looks like. It's going to match this structure here. So we'll say campaign ID 1, name, summer lunch. Next we will have the due date. And for this we can say datetime.now to just generate a datetime for us. And this will need imported. So you can say from datetime import datetime, or just type that out manually. And then for the timestamp of when it's created, it'll be the same thing. So created at datetime.now. That'll just make it easier for us. And then we'll do the same thing down here for the next one. We'll just change some of the values. So we'll make this 2. And then for this, we could say Black Friday. Now taking a look at these problems, it's going to complain about the types. Now we can get into the details of how typing works and all that right now, but it doesn't really make sense until we get to actually working with the database. So I'm going to show you now how you can basically ignore this, as this is just kind of a fill-in so we can get the API interface built. So to do that, we'll say from typing import any, and then you can put a colon any. So again, we'll circle back to types here soon. But for now, we should be good. And our endpoint will return that array inside of campaigns. So let's go refresh, and you can see our new JSON structure here. Now, if you want, you can go into inspect, and you can take a look at the network tab, do a refresh. You'll see that request here, and you can get more information about it. So this will format the response data. You can also click this button here, which will format it. But you can also take a look at the headers. So we have a response code of 200, and the request method was get. And then the content type for the response, application JSON. Next up, let's talk about how to get a single campaign. So just the details of one of these campaigns, not the full list. So this will teach us how to get an ID through the URL. So we'll say app.get, and the path will be pretty much the same with an additional /ID. So campaigns / same structure as we talked about in earlier lessons with the curly braces. And this is going to be given as a parameter to the function. So our function will be read campaign singular, and then we can say ID with a type hint of int. And then we will return, just to test this one out, we're going to say campaign, and let's just return the ID that we actually passed to it. So we can go to the page, go to campaigns /1, and it'll just echo that number back to us so we can see that the number travels through the web page and comes back. So now what we can do is we can use that ID to grab the appropriate campaign. So how would we do that? We'll basically keep this real simple. For campaign in data, if campaign dot get, and then here you will put the key of the dictionary you're looking for, the campaign ID. Compare that to the ID that was passed in. So when we access this, it'll give us a number. We check if it's the same number we're looking for. If so, then we return that campaign. Otherwise, if we get through the loop, we can raise an HTTP exception, and this is imported from FastAPI, and then you'll pass a status code here. So status code is 404. So let's check this out. We'll go to campaigns and we'll try a 5. It'll give us not found. And then we'll try a 1 and it gives us that ID, but I don't actually want to return the ID. I want to return the campaign. All right, so now we do a refresh and we get that data. Looks good. And this is what the structure looks like when we pretty print. Okay, cool. So we've shown one way of working with this API. Works pretty well. We've also talked a little bit about using the docs page, but we haven't used it a lot. So maybe let's take a look at that real quick. So we'll just go back to docs, do a refresh, and you'll see we have a couple additional endpoints here. And this will give you some extra details. We haven't talked about putting the correct type structure here. We'll get to that once we start working with the database. But what you can do is you can try it now and you can put in the value here, execute, and that's going to give you the data as well. So either way you want to work with it is fine. It'll be handy once we get to other methods such as post. You can just do that right from within the docs page. Now let's go in and create app.post. This is going to be at campaigns with no ID, and then the function is going to be called create campaign. You can name it whatever you want, by the way. I'm just following the CRUD acronym, create, read, update, delete. Now we have the ability to read data from the request body. So for this, we'll say request is request with a capital R, and this will be imported from FastAPI. And to get the body, we'll say body is request.json. And this being an async function, we have to await this call. Now we can craft a new campaign, which will be a dictionary following this similar structure. So I will copy this. We'll paste that here. And instead of a 2 here, we will actually just use a random ID for this. So we can say random or randint, and we'll just get a value between 100 and 1,000. This will need imported from random. So from random, import randint. And then for the name, we can get that from the body. So you can say body.get name. And then for the due date and created date, again, we can just ignore those and generate values here. Well, actually, with creating a new one, we might want to specify the due date. So let's practice that as well. So we'll say body.get due date. So we'll take a look at how to pass a date time from the request body. Now, once we have this new dictionary, we can just append it to our data list. So we'll say data.append, passing in new. And then we will return this newly created element. So we'll say campaign is new. And we will type this to any. So now, how do we actually make a post request? Well, we're not going to be able to do it from the URL up here. So that's where the docs come in handy. So we'll see the post here. Try it out now. And we have the ability now to provide a body. I think we were pretty close. I think we just need to change one thing to get the request body to show up in the docs. And that is, instead of working with this request, and then getting the body by saying request.json, we can just work with the body directly. And when we do that, FastAPI knows that we're expecting some content in the body for the request. So it's going to add that option to submit the body in the docs. So you'll see what I mean in a sec. If we just replace this with body, and then we type that to a dictionary, which is a generic, and a dictionary is going to be key value pairs, string to pretty much anything. So we'll say stir any, and then we can remove this line here. So now FastAPI looks at this and says, oh, we're expecting a body in this request. So we do a refresh, and now we see this request body. So when we try it out, we can fill in the values. So name, example campaign, and then execute. Scroll down, you'll see the response. We get a 200. It gives us a campaign ID of 999, which was generated for us, and name example campaign, and then the due date and all. So if we wanted to pass in a due date, we would just put in a format of this nature. So example campaign 2, and then we can say due date, and then as a string, the year, month, day, and then the time, hour, minute, second, and then microseconds. Execute, and there we go. So now when we go in and grab all of our campaigns, try it out and execute, we should get those new ones in that list as well. So those will persist as long as the application is running. Once they reset it, it'll go back to just the 2. So it's all in memory. I want to talk now about updating data, which works pretty similar to creating new data. The only difference is we use an ID of something that already exists. And we're going to use a put request, so we'll basically replace that entire campaign. So anything we want to stay the same, we'll just leave it as is, but we'll keep that in our request. So we'll say app.put, path will be campaigns/ID. And then this will be update, so update campaign. Same idea, we'll have a body, which will be a dictionary containing a string, and then anything for the value. And now let's find that element in the dictionary and update it. So we will use an enumerate loop. So for that, we'll say for index campaign in enumerate, passing in the data list from up here. Then we'll check if, check the ID, campaign.get, campaign ID is equal to, oh, we also need to get this ID as a parameter. So that'll be ID, and that will be of type int. So then we can use that here. We can now craft an updated campaign. So it's basically going to look like this new one. So I'm going to copy and paste that here. Then we'll just adjust the indentation. And we will call this updated. The campaign ID will come from the existing ID. So that'll just be the same as the ID for the campaign we're looking to replace that we pass in as an argument. And then for the created at, we're not going to actually replace that with a new time. We'll keep the same time. So this should act like a patch where we don't have to provide that as the client. It's just handled by the backend, and not providing it is not going to cause that attribute to be removed from the campaign. Hopefully I'm making some sense, but probably not. Basically, we just need to have the backend handle the created at, and for an update, we don't want to give a new created at date. It's an update, not a new element. So we'll just grab the original created at. So campaign.get created at. Also, I just realized I had a typo there. So at this point, we have an updated campaign. I'm just going to fix some of this indentation so it's clearer. So what we need to do now is go into the original campaign list and replace the one with this ID with our new updated data. So to do that, we'll say data, and then the index will be from this index thanks to the enumerate. And then we'll set this to updated. And if we get through all of the loop and still didn't find it, we can raise an HTTP exception with a status code of 404. So far, so good. I think that'll do it. The only other thing is, what do we want to return with an update? Typically, that's going to be the updated data. So I'll put that inside of a dictionary, and we'll just say campaign and set that equal to updated. So let's give this a run and see how it goes. We'll do a refresh on the docs, and let's just get the latest data so we can see what we got. So the server restarted. We got 1 and 2. Let's take 2. And then for our put, we will try it out. We'll replace this document entirely. Let's change it to Cyber Monday. We don't need to provide the created at, and we can change his due date to whatever we want. Let's just move it a couple of days forward. Execute. Oh, and then the ID, we don't want to pass it in the body. We want to pass it in the URL path. So we'll remove that there. Scroll down, execute. Let's take a look. All right, so we're getting a 422, which basically means something's wrong with our syntax, and that is this trailing comma. So execute 200. Response body is the new updated data. You can see it has the same ID, should have the same created at, but it has our updated name and due date. Then when we go and retrieve all of the elements, that change should be visible there as well. Last one I want to worry about is deleting. Just so I don't have to start from 0, I'm just going to copy and paste the update, but we're going to change it from put to delete. We will still need the ID of which one to delete, but we're not going to provide a body, so we can remove that. And then we'll iterate through. If the campaign ID matches, it's very simple. We don't need to do all this. We can just say data.pop and pass in the index. And then we won't return the campaign. We can just return a response and pass in a status code. And I don't think we're getting that suggestion because this needs imported. So from FastAPI import response. And then status code is 204, no content. An additional place where you can specify the status code to be returned, such as in the case of creating, we can add in an additional argument to the decorator here and say status code is 201. And that will give us back the data, but it'll come with the 201 status code. Let's check our campaigns. All right, so we got 1 and 2. Let's delete 2. So we'll go to delete. All we have to do is provide an ID, execute, and we get a 204. If we run it again, we get a 404, which is expected because that document doesn't exist any longer. And if we go up and retrieve all of them, it's not in that list. All right, so at this point, we have a pretty decent structure. Most of the endpoints are what they're going to look like with our final product. We're just going to add in the database now. So we're actually storing that on disk instead of just in memory in a dictionary. With this, we're also going to introduce custom types. So the interface for the API will change slightly. It'll pretty much be the same way to interact with it, but the documentation will have specific types. So it's actually just going to get clearer, not actually change the way you interact with the API. This is why I like to mock data for simple examples or when I am learning a new framework, because basically I can think of the end user, what they're going to interact with, separating that from complexities that may make it more difficult to progress. So now that we have that interface, we can just substitute out the data layer for something better and continually improve on our API. Plus, there's a little bit of a learning curve here. Some of the database setup is a little complicated, but it's not too bad. Once you have it set up, you can pretty much ignore it. But for that initial structure, you will need to do a couple of things because we'll need to define our models and so forth. So I'm going to walk you through that now. Before we get started though, I'm going to add everything to the repo. And I haven't pushed this anywhere, but if you wanted to, you could git push origin main or whatever. So we have that created. I didn't add the PyCache to the git ignore, which probably would have been smart, but it's not the end of the world. So what do we use to connect to a database? There are various options. I'm going to go with an ORM, an object relational mapper. This will basically take database records and convert them to objects in our code, so it's very easy to work with the database just through those objects. It allows us to kind of skip over SQL because it does a lot of that for us. ORMs can have limitations and challenges, but I think it's a great place to start. Now, when it comes to what ORM to use, there are a few different ones. Big one here is SQL Alchemy and SQL Model. Now, SQL Model is often recommended with FastAPI. It's by the same creators. And you can think of it as basically a combination of SQL Alchemy and Pydantic for typing. So that's something I want anyways. I'm going to go this route. But you could, of course, use SQL Alchemy or any other ORM you're interested in. So we will say pip install SQL Model and then pip freeze to our requirements file to update that. Now, much of the database connection information can be found in the FastAPI docs. So tutorial user guide, and then there's a section for relational databases. And they have the connection code here. So this is where I'm getting most of the stuff. And if you want to know all the juicy details, I have additional information in the notes for this lesson, and you can go to the docs as well. But basically, we start by creating an engine variable, and this is our connection to SQLite. This being an ORM, you can easily swap this out to another database. So even if you're going to be using Postgres or some other database, this is going to be pretty much the same. The only major thing that will change is the connection URL. Getting started with SQLite is probably recommended though for learning's sake. And then we use check same threads to false, allowing FastAPI to use the same SQLite database in different threads. We then create the initial tables. We will create a session, and this will use the engine to communicate with the database. The session keeps track of any changes needed in the data and is the thing that actually interacts with the database. We will create a FastAPI dependency with yield that will provide a new session for each request. This is what ensures that we use a single session per request. And then basically we can pass that session around very easily, so we don't have to do a bunch of work. So we'll create this session dependency and then pass that to anything that needs it. So an example of that would be this here. We just provide that session to our handler, and then we can use it in our code. And then the last thing really is this on startup. We will create the database in tables. I changed it a bit from what's here as I was getting deprecation warnings, so I found a more up-to-date way of doing it. And then here's an example query. We use session.exec. This will allow us to do arbitrary queries. Or if you're just reading one thing, then you can use session.get. So we'll see that as well. So in our code, we will first create the SQLite URL. SQLite file name is database.db, and this will just be created in your current working directory. So from where you run the file, in this case, running it from the same directory, it'll just put it right here. From this, we will create the connection string. This will be an F string, SQLite colon, and then 3 slashes, SQLite file name, making sure to spell all that correctly. And then any additional arguments. The big one here is being check same thread, setting that to false. And then we create the engine variable that we'll use for the rest of the interaction with the database. Create engine, passing in the SQLite URL, and then the connect args is a named parameter, so connect args is connect args. Create engine, this will need to be imported. If you're given the option, go for the SQL model version. A lot of these things will exist in SQL Alchemy as SQL model is built on top of SQL Alchemy. So if you end up switching to SQL Alchemy at some point, you're already going to have a lot of this practiced. Next, we will create our function to create the tables. Create DB and tables. SQL model dot metadata dot create all, passing in the engine. This will be imported from SQL model. Next, we will have get session. We'll use a context manager here with session engine as session yield session. And then we'll import session from SQL model. And here we will create the session dependency that we will pass around. We will use annotated, passing in session, and depends on get session. And this should not be within get session, this should be unindented. And then depends is imported from FastAPI. Now for creating the database on startup, this is what is recommended in the docs. However, then I found these lifespan events, and this will be something that runs at startup or shutdown logic using the lifespan parameter of the FastAPI app. And a context manager, you can see an example, it'll have a yield in it, and everything before the yield runs at startup and everything after the yield runs after. So this will be used for releasing resources. And then you'll pass this lifespan to FastAPI and it'll invoke this when the app runs. So this is pretty much the structure we're going to follow. So we'll come down here. Async context manager. Honestly, don't even know what some of this stuff does. Definitely need to sharpen up on my skills, but that's okay. So we'll have a yield here, which will basically pause execution for the next run of this. Anything before will be done at the beginning. So create DB and tables. And then here where we are creating our app instance, we will say lifespan is lifespan. So when we run this, you should see in your files a database.db. So it should create the database for you. If it doesn't, then you might not be connecting this lifespan properly to execute this function, or you forgot to put this function here, or this create DB and tables function is not doing anything. So check all of those pieces. But yeah, that's the cool thing. Basically, anytime you mess up or you just want to restart, you can just delete that. No problem, just recreate it. And because of that, I like to usually seed the database with some data. So basically start off with 2 rows, sort of how we did in this example, but instead of just this dictionary, we will insert some data into the database table. So I'll show you how to do that as well. So right after the database and tables are created, we can say with session engine. So this is a context manager that will automatically free any resources. So we have a connection with the database. If not session.exec, and this is where we can invoke a query and see if we get a result back. If so, that means we've already done this. So it's kind of like create table if not exists, but instead it's with an insert. So we're going to check to see if the table has any data. If it does, we're going to do nothing. If it doesn't, we're going to create 2 rows. So we'll say select, and this will be imported from SQL model. And I'm actually hitting roadblock here because we need to use our custom type, which we haven't actually created yet. So let's just pause on this, because this is a great idea, so we have some data to work with right from the get-go, but we'll pause until we get our type built. So let's take a look at building our type. We'll scroll up to the top, and here we can craft our data type. So class campaign, and we'll pretty much match this structure here, but we have to do it with the special syntax to create a model for SQL model. So to do that, we use inheritance, so SQL model. This is how SQL model is going to know that this class is a type for the database. Additionally, we'll explicitly say that this is associated with a table, so table is true. And this is important because we'll create some other types for our API based on this campaign, but it's not directly connected with a database table. But this one will be, so we'll set that to true. And the syntax here is you will use class level variables for all of your fields. So the first one we're going to have is going to be campaign ID. And this is what the syntax will look like. We'll say the type that it can be, either int or none. And then we will use equals field, passing in any customization such as a default, or if it's the primary key. So campaign ID will be int or none. Assign this field. This will need imported. default will be none. This will be handled at the database level, so it should auto increment, but we will want to make sure we set primary key to true. Next up, we will have the name. This will be a string, and we'll set this field. And you can also set indexes in here, so we'll say index is true so we can easily work with the name attribute. Next up, we'll have a due date. This will be a date time or none, and we will make this a field. We will have a default of none, and we will index this, so index true. So this due date I intend for the user to be able to set. So you can basically say, hey, this is when the campaign finishes. So that way everything can be described relative to that date. Like, hey, this post needs to go out a day before the due date. Then we will also have a created at, and this I'm thinking more of a timestamp at the database level. So this will be a date time. This will be field, and we're going to do something a little bit different here for the default. Now you could generate this at the application level or at the database level. I'm just going to generate a date time value here. So I'll come back to this in just a second, and we'll say nullable is true and index is true. So for the default, you can put a function name. However, you don't actually invoke the function here, so you don't use parentheses. Now, what I want to do in this specific scenario is I want to put a function, but also give that function some arguments. And to do that without using the parentheses, you can use a lambda function. Basically, an anonymous function will define here. So it's going to look a little strange if you haven't used lambda before, but basically it's going to look like lambda colon date time dot now. And now you can use the parentheses here because the actual datetime.now is not going to be invoked immediately. And then here you can say time zone dot UTC. And I think I have a couple of issues here. So we need to fix the spelling, and then this is going to need imported time zone add from datetime. So let me just run through this one more time. Basically, I want to invoke the datetime.now function, so you could just use that name directly without the parentheses. But because I want to provide a value for this, I basically have to wrap it in another function that will be invoked later on. You can think of this as a function that all it does is invoke another function passing an argument to it. Okay, cool. So this is the model that we're going to do everything through. And what we can do now is we can go create two of these right after we create the database in tables. So I'm going to uncomment these lines. And first we will check to see if any data is there. So we'll say campaign, select campaign, and then we can use dot first. So if this doesn't return any data, then what we can do is we can insert two rows. Session dot add all. This will take a list, and in here we'll just define these as instances of the campaign type. So name, summer launch, due date, you can say date time dot now, and we'll do something very similar for the next one. We'll just change this to something else such as Black Friday, and then separate these by commas. After the session.add, we'll say session.commit. And let's see, we got an error. Let's check what's going on. I think it's just not seeing those columns. So it may be the case that the table's not being created or there's some other disconnect. So let me just look around here. So we have the create DB in tables. That all looks good so far. We have our model here. It could be the case that maybe once we created the database initially, we didn't have these there, and we didn't have our model complete entirely, as I know the server was refreshing as we were changing. So just to be on the safe side, I'm just going to delete the database, make sure it creates the right tables based off of this model, and then inserts that data immediately after, so everything's lined up. So I'll just close out of the server and run it again. That wasn't quite it. I have one other thing I'm going to check, and yeah, it's this default here. There's one little change we need to make here. Because we're actually using a callable, we're not using a value. This is going to be default factory. So save that, and it looks like the application was able to start up, so that's great. And what we'll be able to do now is we'll be able to retrieve data from the database, and we should already have these two campaigns preloaded in that database. So I came down here to our endpoints, and I'm going to comment these out, all of them, because basically we're going to recreate these, and it's probably honestly easier to just use them for a reference as needed and just focus on creating new ones that use the database. So let's first recreate this one here, /campaigns. So we'll say app.get /campaigns, async def read campaigns. Now, since we'll be working with the database, what you'll be doing is you'll be passing around this session object we created somewhere, this here. So we'll copy that. And inside of our parameter list, we'll say session is session dep. Now to retrieve the data, we'll say data is session.exec, select campaign, and we will want to invoke all. So that's what you'll use when you want to retrieve multiple values. And then we'll return data, but we want to wrap that in a dictionary as we've done. So similar idea to what we did here. So we'll say campaigns is data. So taking a look at our endpoints now, we have the list of campaigns. We will try it out now, execute, and you can see we get 2 campaigns back, one being the summer launch and one being the Black Friday sale. Now the due date is pretty much going to be the same because I just generated it as datetime.now, but you could definitely set a custom value in the database seeding up here. So far so good. I mean, it works. So now we just have to continue on by replacing the rest of these functions. However, before we do that, I want to take a quick break to talk about the types. So if you look back over at the documentation, we can see the response structure here. But if you look at the expected structure, it just says string. Basically, it doesn't know what the expected structure is, so it doesn't give us much information. So we need to change what that structure is, so that way people who are using this docs page know what to expect. And that's really important. So when we look at an overview of our API, we'll be able to see what types are used and how to interact with the API properly. Additionally, you might be able to generate client code based on this documentation. So the easiest way to do this is to create a class campaigns response. This is going to be our custom response type. We can structure it however we want. Now for basic validation, you can inherit from base model. For this, we will import it from Pydantic. And then inside of here, we just structure what we're expecting, which is the campaigns. And this is going to be a list of type campaign. You can then specify the response model. Response underscore model is campaigns response. Save. It looks to be good. What we can do now is go over to the docs, do a refresh, and you'll notice that we now have the proper structure expected as a response. Now in the notes, I have a bunch of variations you might see for the typing, but ultimately I decided on this approach for various reasons that make this better, so you can read additional information there. This allows me to get the exact structure that I'm expecting, and I think it's the cleanest of all the different options. Let's now work on replacing the next function here, which is to get by ID. So we'll copy a lot of this here, app.get /campaigns/ID. We're going to ignore the response model for a moment. Let's just get this function structured. We'll say async def read campaign, ID is int. And now we can say data is session.get. So if you're going to be retrieving multiple values or anything else, you'll use session.exec. But if we're retrieving a single value, you can do session.get. You'll say from what table and then the ID you're going to use. And then the session, we need to pass that in as well. So that's going to be session is capital session dep. And then it's just a simple check. If not data, then we can 404 raise HTTP exception status code 404. Otherwise, we can return data. Similar idea, we'll wrap this in a dictionary. So it'll be campaign is data. So I think that's good. Let's check it and then we'll worry about the type in a moment. So we'll come back over here, do a refresh. We should see campaign/ID. Notice there's no good typing down here, but ignore that for a moment. try it out. We'll try ID 2. Let's check what the actual IDs are here. So you can see them, campaign ID 1 and campaign ID 2. So let's do 2. We run that and we get just that campaign back. Okay, so for the response type, basically you can do the same exact thing, but instead of it being a list, it would just be a single value. So you would have to create a new custom type. And then you're going to be creating a bunch of custom types for all the different endpoints. So because of this, I want to introduce the idea of a generic type. Basically what I want to do is I want to create a type where we don't specifically say what the type here is, we keep it general, that we can reuse for all of our responses. So we'll just change this to be a little bit more general. This will just be a response we can use for all of our endpoints. And instead of the type being a list of campaign, it will be a list of T. And to specify that this is generic, you'll use another parameter here, generic, square brackets, T. And then the last thing, instead of campaigns, we'll use a general word for the dictionary key, such as data. All right, let's see what else needs imported or anything like that. Add from typing, import generic. Now, we haven't really talked a ton about types. We've been using them. We've been using the type hints from Python up in the models like we did here. But basically, throughout this, if you've seen square brackets after a type, it's a generic type. So I think in the previous example we just had, let me back up a second. We had here list and then campaign in square brackets. This was basically saying, hey, we're creating a list and that list is going to be of type campaign. So everything in that list would be a consistent type. That same idea will be done now, but we're creating our own type that we can provide a type to. So if you have never done generic programming, it's basically a layer of abstraction, one level higher thinking, and that can be pretty challenging if you're new. But basically what we're going to do now is we're going to provide what type we want to use when we use this response type. It's basically like a placeholder that we can provide a value here for. But instead of that value being a value like a specific campaign, it's a type. So the thing that we're substituting in is a type, not some value. So let's see what that would look like. Instead of using campaign's response, it will now use the response type, the generic one we created. And then because this is a generic, we have to provide the type that we want to substitute in right here inside of square brackets. So here we can just put what we used to have there, which was a list of type campaign. So this functionally works the same way. We're just creating our own generic type now. Now, last thing to get this T to work, we'll just say T is type var and then the string T. And then for type var, this will be imported from typing. All right, and it looks like everything is good to go. All right, so now we have this custom type, a little bit of extra work, but we can use this type for both of these. So now down here for getting by ID, we can do a similar thing where we say response model, and the type will be response. And the type we're going to provide to substitute here for T, instead of this being a list of campaign, it will just be a single campaign, so campaign. So now when we go over to our docs page, it's going to say the response has a data attribute. And that's one of the trade-offs here. Basically, it's always going to be data, but then the user knows it's consistently going to be the same attribute. So what that means is for these returns, we'll just change this to data. So now they're consistent, but the structure for data here is a little bit different. One is a list of campaign and one is a campaign. All right, let's do a refresh now. Check it out. So we have data, it's an array, and then we have by ID, it's data where it's an object. So far, so good. I also have noticed here a import of name response, which is the same name that we're using for this response here. I don't think we're using response for anything, so I'm just going to remove that. I think we're using that down here for the delete, but we're not going to need that anymore. But if you were going to need that, then you might want to just alias this or change the name of your custom type. All right, cool. So we replaced this get by ID. So let's remove that one. Now let's talk about creating data. So we'll say app.post, and we will have this the same path, campaigns, status code 201, response model. The create typically returns that new campaign. So it's going to be the same type as getting a campaign by ID. And then we'll create the function, create campaign. And what we can do here is we can specify a custom type that we expect from the body. So this will be pretty much exactly what we did here. However, a couple of small differences. Instead of, manually saying, hey, it's a dictionary with string keys and then any value, we can use our now custom type that we created up here, the campaign type. So it's a more direct type where it knows what the different attributes are going to be instead of just saying, hey, they're string keys. Additionally, we can rename the variable. Instead of just body, we could say that it's called campaign. So it'll look something like this. Campaign is of type campaign. Additionally, we will have session, as we've done for the other functions as well. Now to add data, we'll say session.add, pass in the campaign that was passed in the body, session.commit, and then what you can do is you can do a session.refresh, and this will make sure that the campaign that you're working with has the most up-to-date data from the database. And then we can return data is campaign. So basically, when you create the data in the database might do additional stuff. For example, it gives it an ID, it gives it a created at timestamp, or it might do any transformations. And we need a colon right there. So what this refresh does is it just makes sure that we get all of that information in the campaign variable. So when we return it back to the user, it has all of that new data. At this point, we're not going to need rand_int anymore. So we'll just remove that altogether. And let's run this, give it a shot. So do a refresh here. You can now see we have the post. It gives us an example value, which is pretty handy. So we'll try it out. Execute, and we get an internal server error. So let's take a look at this error. We'll go to the terminal, and it complains about the date, time, and date objects as input. This has something to do with the timestamp values and the created at. So if you look at what we're providing, we have the due date and the created at being given here, as well as the campaign ID. So basically what's happening is the expected structure is a little bit different than what we actually want. We don't want the user to provide the campaign ID or the created at, and that's causing issues at some point with this error we're getting. So what we actually want to do is we want to create a type that's just a little bit different, where it doesn't expect the campaign ID and it doesn't expect the created at, since those are going to be done server side. So really, this is what the structure we want to use should look like. So to do this, we'll create another type here, and this will be a campaign create. So for this, I prefix with the larger type campaign and then follow it up with the operation. And I'd say that's a pretty good convention. So then we have, if we have multiple variations of this, they all start with campaign, and it's very easy to find that type. And then this is going to inherit from SQL model, but we're not going to set table to true because this is not going to directly associate to a table. As the table has 4 attributes, this is only going to have 2. So it's a little bit different than this campaign up here. So now for the attributes, all we need to do is say the type. Since we're not mapping directly to a table, we're just worried about the Python types here. And then due date will be date time or none. And we will provide a default value of none. Now we'll go back down to our create function. So right here, and we're no longer expecting a campaign, we're expecting a campaign create. However, this is now going to lack some of the automatic processing. So what we need to do is we need to do one additional thing. We basically need to validate it against the database structure. So DB campaign. Then we'll use the type that is associated with the table, which in our case is campaign. And there should be a model validate. And this will take a pedantic model, meaning just like a structure for validation that's not associated with the database. It'll take an instance and validate it against the database structure. So we can pass in our campaign object here. Then we will use this new variable db campaign for the rest of this code here. So let's test this out now. You can see the expected type is now proper. Try it out, execute. We're still getting an internal server error, so let's check it out. So it says unhashable type list. And that is a mistake on my part because this should be a string key, so not the data variable, which is a list from somewhere else in our code. So let's try it now. We'll do a refresh. Try it out, execute, scroll down, and here's our response body. You can see it created the data, it gave it an ID, it gave it a created at, and it kept our due date and name. So now we could go in here, we could create any with custom values. So maybe it's a Christmas sale, execute, and there you go. Wow, that was quite a bit of work, but we got it working, so that's good to know. All right, cool. So we've completed creating a campaign. We can now worry about updating a campaign. app.put /campaigns ID. Response model will be our custom response type, and then this will return a single campaign, and then we'll say async def. I think earlier I got these function names backwards. I don't know how I managed to do that, but we had update campaign, and then we had delete campaign. So update campaign for this new one. We'll take the campaign ID, which will be an int, and then we will parse the body, call it campaign, and this will be of type campaign. And actually, we can just use the campaign create type here for the update, as we only need the name and the due date. Those are the only two things we would change. So you could call it something else, or we could create a custom campaign update, but I think this is fine. And then lastly, we will need the session so we can work with the database. Now for this, we're going to first retrieve data from the database. So this will be similar to what we did up here. So I'm going to copy that and paste it here. And we'll make sure this is all lined up properly. So we first get a campaign by ID. If we don't find it, we will raise a 404. But before we just return data, we'll need to update data.name, set that to the campaign that was passed in the bodies .name. Same thing for data.dueDate is going to be campaign.dueDate. Then we do session.add, passing in this data, and a session.commit, and then a session.refresh to get the latest changes from the database. So we're making sure we're actually giving back the correct data. We'll pass in data here as well. And then if all goes well, we can return data. So let's try this out. We will go over to the web page, do a refresh, grab the put, and we will do campaign ID 4, or you can just grab your list of campaigns to see what ones are available. We will change the name to something new, change this due date to 2026, execute. Internal server error, let's check that out. I think this is just a naming issue, as I'm using campaign ID for the parameter, but then I use ID for it down here. So ID is a built-in thing with Python. So throughout this, I've been overriding that. But if it's not something you're directly using, it's not going to be the end of the world. It's probably healthier to use the campaign ID prefix so you're not overriding that. But I guess for consistency's sake, since we've been using ID throughout this whole thing, I'm just going to change this to ID. Let's try this out again. I did a refresh just to make sure. Hit execute. And you can see it updated. Awesome. So we have update campaign done. Now let's talk about deleting a campaign. So app delete campaigns ID. We'll do a status code equals 204 async def delete campaign. ID is of type int, and then we'll have the session. We will retrieve the data, and then we'll just say session.delete, passing in data, and then session commit. And that's pretty much it. Let's try this one out. We'll go over to the web page, do a refresh, open up delete. We will delete 4. Execute. Server response is at 204. Great. For a minute there, I was like, oh, validation error, but no, these are just the possible responses. Cool. So we've pretty much finished up the basic CRUD. Overall, not too bad. I mean, it was pretty brutal getting all of these CRUD capabilities with the model set up. At this point, I think everything's pretty good. We don't need this mock data anymore. And at this point, everything's still in one single file. So obviously, as you grow, you're going to want to break things out into separate files, make things more organized by the type of data you're retrieving. So you might have some dedicated files for campaigns. There's different architecture approaches. So for example, you could put all the campaign stuff together, or you could do it more like an MVC structure where you put all the models together and the views and the controllers. For now, we've covered so much in this one video. I think this is a great stopping point, but I do want to continue this project. So please, if you're enjoying this material, give my channel a subscribe and check out the playlist link for you to go through all of the development content. Reminder, I do have notes with all of the material we talked about and additional resources and links. And additionally, I will commit this to the repo. So git add, git commit, basic db CRUD, git push origin main. Oh yeah, I didn't make a repo, so awkward. So we'll create a repo FastAPI example. Create repo. And then I will push this up to GitHub. Awesome. So now you should be able to find this at this URL as well. A couple other minor changes. I'm going to remove this nullable true. I don't think we need that if the database is always creating the timestamp. Then we don't want to be able to set it to null. For the due date seeded data, I'm going to make sure I do timezone.utc just for consistency with how we're creating timestamps, but it's not really a huge deal. Thank you so much for watching. Hopefully this is helpful. There's still a lot to learn. Some ideas I have are talking about relationships, which is a huge one for databases, pagination and URL parameters, organizing our code and different architectures, middleware, that's a huge one, and user authentication and so much more. So please stay tuned for the upcoming lessons. I'm really excited for this content. I look forward to seeing you there. Goodbye.